Which of the following is or wave-like properties of an electron? Choose all that apply. So if this were on your homework, it would have, let's just use blue, little square boxes here. I've done my best on exam number 2 that to note wherever there are square boxes that you may choose all that apply. If you see little circles next to it, that means there's only one answer. But squares mean multiple answers are possible. It says, which of the following is our wave-like properties of an electron? So what we will check here is, first off, electrons have a wavelength, and that is definitely a wave-like property. Electrons do not have a frequency. Only photons, only wavelengths of light have a frequency. Energy and mass, let's say this. So let's go through this. So an electron has a wavelength, and we just calculated it. It goes like this. Wavelength of an electron equals h over mv. So that's the equation we can think of for this. Electrons do not have a frequency. So we will leave that one blank. Energy, electrons do not have an energy either. Electrons do have a mass. Mass is a particle-like property. And an interference pattern for a double slit experiment is a wave-like property. So we've got 2 answers here. Now, when you do this question, there are multiple options here. So another question is, which of the following is or particle-like properties of an electron? And there are 2 particle-like properties of an electron. Those are mass and position. And if you have mass, if you exist as having mass, you also have a position or a place that you can be. Now there are also wave-like properties. Wave-like properties of a photon of electromagnetic radiation, or a photon of light. I can't remember what it says, actually. I can't remember if it says wave-like properties of a photon of light. It might also say a photon of electromagnetic radiation. And the wave-like properties would be wavelength, photons do have frequency, and photons do cause an interference pattern. So, and maybe this one I think makes more sense. We're used to thinking of a photon, which when we draw a photon, it has a wavelength and a frequency. So we're used to thinking of these things for photons. Lastly, and the last one you can get is the particle-like properties of a photon. And what's interesting is that a photon has no mass. So how can it act like a particle? And totes, I totally get that. This is the hard part. But the photon can move an electron from between energy levels in an atom. And we just talked about that on the last question. We said that a photon can move it between n equals 1 and n equals 2, n equals 2 and n equals 3. So this is the particle-like property. And how it does it is it uses its energy. So energy is the particle-like property of a photon, because it uses its energy to push, to move. And so you can imagine that if you have moved something, then you're acting like you bumped into it. Even if you don't have mass, you're acting like you had mass. Any questions about that? Let's see if I can get it all on screen here. Okay. Well, that was 4.